This is the Algebra 1 Unit 9b test review. You'll need a calculator and a formula chart for this review. So the first thing we're going to talk about is the parent quadratic function, and that equation is y equals x squared. Remember, that can also be written in function notation as f of x equals x squared, and you do have to have that memorized for the test. If we're going to graph this, the easiest thing to do would be to plug that in our y equals in our calculator and then look at our table. So I have done that, and I'm going to graph -2, 4, -1, 1, 0, 0, and then 1, 1, and then 2, 4. So that is the parent quadratic function. It is symmetrical about the y-axis. And then D and E are either domain and range. So one of them is the set of all non-negative, so that means positive numbers, so that is going to be the range. We would normally, for this one, write the range y is greater than or equal to 0. And then our domain, just as it is for every parabola that opens up or down, is always all real numbers. For number 2, we're going to identify all of those different pieces. So first thing is the zeros, which are also called the solutions or the x-intercepts or the roots. So I just marked them. So one of them would be 2, and the other one would be -6. I'm going to write those in set notation. You can write them in any order. Probably if it were a multiple choice question, the -6 would come first. Remember that you can also write them as an ordered pair. You could say 2, 0, -6, 0. Then the vertex is the highest or the lowest point. So it's the highest point in this case, and that's going to be -2, 4. And the vertex helps us out with the axis of symmetry and the range. So I'm actually going to skip to those. The axis of symmetry is this imaginary line that I just put a dotted line for, that our graph is symmetrical about, and that is always written as a vertical line equation. So that's going to be x equals -2. So notice the x value of your vertex also goes with your axis of symmetry. Then for your range, you're going to use the y part of your vertex. We know range has to do with y. And then since this is a maximal point, we know that everything else is below, so it's going to be less than or equal to 4. Then let's do our y-intercept. So I'm just going to go to the point on the graph where it touches the y-axis, and that's going to be 0, 3. And then our domain for any parabola that opens up or down is always all real numbers. For number 3, it says write the new equation that would result if y equals x squared minus 3 were translated down 10 units. So if we want to go down 10 units, that means we're going to subtract 10 from the -3. So the new equation would be y equals x squared minus 13. Number 4 says, how would you change the graph of y equals x squared to produce the graph of y equals x squared plus 9? Well, this plus 9 means that we would have to shift up 9 units. On number 5, we're going to look at how that graph is going to be different from your parent function, which would happen to be quadratic. So I'm going to look at the negative first. The negative means that it would reflect the 1/2 controls whether it gets narrower or wider, and since it is less than 1, it's going to get wider. And then finally the -2 at the end means that it is going to shift down 2 units. When we look at number 6, we're still comparing. And we want to know how would the graph of the function x squared plus 4 be affected if it were changed to x squared plus 1. So we're going from a +4 to a +1, so it's going to shift down 3 units, which would be G. For number 6 and 7, you need to grab your calculator. Anytime you want to know how many solutions one of your equations has, it has to be set equal to 0. And then you can plug it in and see into your y equals and look at the graph to see how many times it touches the x-axis. So I've already put number 7 in y equals. Now I'm going to press graph. And what we're looking for is to see how many times it touches the x-axis. Since it does not touch the x-axis, that means it's going to be no solution. Then we're going to do the same thing for number 8, except before we do number 8, we have to set it equal to 0. So I'm going to minus 10 from both sides. So 0 equals x squared minus 5x minus 10. And I'm going to go to my y equals, clear that out. X squared minus 5x minus 10 and graph. Remember, if you can't see anything, you might have to change your settings. And that one's easy to see that we have 2 solutions. Now, when it asks us a question like this, we don't actually have to say what the solutions are. We just have to say how many there are. Okay, then if we look at the next one, number 9, we need to graph that function. We're just going to put that in our y equals, and we're going to go to our table and grab some points to graph. In Algebra 2, you will do some of this by hand. So second graph to look at our table. And we can plot any point that's between, that looks like a 10 by 10. So we could plot -5, -9. Or excuse me, +9. Let me go the right way. And then we could plot -4, 2. And then we can plot -3, -3, -3, -3, -2, -6. -1, -7, and then 0, -6. So you'll see now that we're coming on our upswing as far as our symmetry. So just another way that you could actually finish this is if you sketch the axis of symmetry, because I could definitely look at that and keep plotting my points. But you can also use your axis of symmetry. So if I went 1 to the axis of symmetry, I would go 1 past. 1, 2, 1, 2. And you would put your dot. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. So that's just another way. Once you get 1/2 of your parabola, you know you can finish it with the other way. B says identify the vertex and axis of symmetry. So the vertex is the lowest or the highest point. So the lowest point in this case is going to be -1, -7. And then our axis of symmetry is always going to be dealing with this x part, and it's always written as a vertical line, so x equals -1. The range is always going to be dealing with the y value of the vertex, and in this case, since it's a minimum point, everything is going to be greater than or equal to that point, so I put a y, and then I put the -7. Remember that if it asks you for the domain, as long as it opens up or down, it is all real numbers. So for 10 through 12, we just need to tell whether it has a minimum or a maximum value, then find that point. So we're going to use the calculator for this one. They're all set up nicely for us. We don't have to move anything around. And we're going to put the first one in, plus 7x, plus 8. We're going to graph it. Oops, I think I missed an x. So I'm going to go back over to the y equals as soon as it'll let me. So I'm going to put 7x plus 8, then hit graph. So that is going to be a minimum, and then to find our minimum, we hit second trace. And you do need to make sure you look as to see whether it's a maximum or minimum before you hit that, because it's a minimum, we'll hit number 3. Then I'm going to arrow down so I get to that lowest point. And then you have to set your boundaries. So from that lowest point, I'm going to go a few times left. There's no set amount. A few times right. Just make sure you're not right at the bottom. You're looking for these arrows, and they should be pointing towards each other. So now I'm going to set my right boundary. You'll see that other right arrow. And then you don't want to guess, so you're going to press enter one more time. So the minimum would be 3.5, comma, negative 4.25. I'm going to put number 11 in the calculator and then look at it on the graph. You can go ahead and try this one because I won't show all my steps on the video. So I've got that graphed, but I need to change my window a little bit. If you like to zoom out, you could push zoom out and then press enter. I don't think that would give us the prettiest graph, but I could change my Y value. So I'm going to go to the window, and I like to change both of them to where if I change one, I change the other. So I'm going to make it negative 20 and positive 20, and then I'm going to hit graph. And now I'm going to go through the process of doing my second trace and pressing number 5, pressing maximum and then setting my boundaries. Okay, so my maximum is on the calculator. That is going to be negative 0.25, comma 10.125. I don't know if it'll give us one like this, but just remember that if you have an E, a capital block letter E, in either of your X or your Y when you're finding the vertex or you're finding the zeros, that number is just 0 written in scientific notation. So I'm going to put number 12 in the calculator. Okay, so I put number 12 in the calculator, and I still have my window changed from last time, and that doesn't look good. So I like to start at zoom 6. I'm just going to start over and see what it looks like. Well, that almost looks like a straight line, so you might want to double check your equation. Make sure you put it in right. So I'm going to do that. 1/4 x squared plus 7x plus 11. So that's right. So we're going to have to change your window. I'm going to actually zoom out this time. 3. Remember, it's not going to do anything until you press enter again. Now, that is a much nicer picture. So that is a minimum point. And now we're going to go through those steps. You may want to make your Y-axis a little bit bigger, only because your cursor is going to be down there in some writing, and you may not be able to see it very well. So I'm going to change that to negative 50, positive 50, and that should make it a little bit easier. So now I'm going to pause and do those steps, second trace, and find the minimum point. Minimum point is on the calculator now, so that minimum would be negative 14 and negative 38. For number 13, you really don't need the calculator. It says which graph shows a function of y equals x squared plus c when c is less than negative 1. And remember, this c out here on the end is the part that makes the graph go up or down. So I'm going to go and put a dot at negative 1 on all of these. And then all we're doing is looking for the one that is less than negative 1. And the only one that is the case is c. Number 14, you can definitely, since it says which set of values best represents the function 6 minus 2x squared when the replacement set of the domain, which we know are the x values, are those 3 numbers. So you can definitely plug in all 3 of those for x. I think the easiest thing to do would be put that equation in y equals, so 6 minus 2x squared, and then look at our table, because it'll tell us every y value for every x value. So if I go to negative 3, I see at negative 3, it would be a negative 12. At negative 1, it would be a 4. And then at 0, it would be a 6. So A would be the correct answer. On these next two, we're going to solve by graphing, but it has to be set equal to 0 first. So first thing I'm going to do is minus 8x. I like to put it in order, even if I'm putting it in the calculator, because the calculator really doesn't care. So there's our equation set equal to 0. So that's going to be x squared minus 8x plus 18. When we're looking for the zeros, we might have to do that twice. And of course, my 8 at the end of my graph did not graph. Or I don't think I got it. Nope. So there's my 18 finally. Now I'm going to go back to the graph. Remember, I'm on those not the standard settings from the last problem. So that's not a very good picture. So I'm going to zoom 6. That always takes you back to your standard 10 by 10 window. Zoom 6. And see what we can see. Well, 15 does not touch the x-axis. So therefore it is no solution. I'm going to have to set this other one equal to 0. So we have x squared minus 4x minus 5 equals 0. So I'm going to go back to the y equals, plug that in, minus 4x minus 5, graph it. Now in this case, and you're welcome to do this, I can tell that that crosses at exactly -1 and exactly 1, 2, 3, 4, 5. So I know those are my two solutions. So that's going to be, in set notation, -1, 5. But I do want to walk through the process at least once to find the zeros. So you would hit second trace, number 2 for 0. Then you would have to arrow. I like to arrow and get as close to that 0 as possible before I set my boundary. So I'm going to hit left a couple, just as long as you're not right on that 0. Notice you have those arrows pop up again. Now I'm just a little bit to the right of that point that I'm trying to find. I press enter. You don't want to guess. And that should tell me it's -1. If it touches the x-axis twice, you have to go through that process again. So second trace, number 2. And I'm going to go all the way around to the other side. Get as close to that 0 as possible. Now I'm going to go left a couple, set my left boundary, right a couple. When you're doing these left and right boundaries, please make sure you're pressing your left and your right arrow keys. I know it seems silly, but you want to press up and down a lot. Press enter, enter, and that should tell us that the other one is 5. Now here's a great example. If you look at my cursor, where I'm going around here, it says the y value is 1e -12. Earlier, I reminded you that that is just a 0. And you should be able to tell by looking here that the y value is 0 when x is 5. Number 17, an object is launched straight up into the air with an initial velocity of 64 feet per second. It's launched from the a height of 6 feet off the ground. The height at h in feet is t seconds is given by the equation that I've already put in, y equals. You can see over there in the calculator. What is the maximum height reached by the object? So a couple of things. Notice you can't put a t in the calculator. You have to put x. Next thing I'm going to do is press graph. And if we're wanting the maximum height, that means we're going to need the y value. Now, here you can see, we can see this part and this part of the graph, but we need to make our y-axis bigger. So I'm going to go to my window, and I'm going to go down, and this is just a guess. I'm going to try 30, -30, +30. Press graph. It may not be enough. I may have to do more. Yep, that's not enough. So I think I'm going to try 60. So I'm going to do -60 for the minimum, +60 for the maximum. Press graph. Oh, not quite enough. I'm going to do it one more time. I'm going to do 80 this time. So sorry, this calculator is super slow. Then I'm going to do -80 and then hit graph, and now we should be able to find the maximum. So that's going to be pressing second trace. Now I can finally see it. So we press second trace and number 4 for maximum, and I'm going to go up to that maximum point as close as I can get, and then set my left boundary. So left 2 or 3, press enter, right 2 or 3. Remember, those are just little estimates. Press enter, enter. So the actual vertex is 270, but remember, the 2 stands for the time that it's at its highest point. So the answer to this question would actually be 70 feet. Number 18, we're standing on top of a 1,680 foot tall building and throw a small object upward. At every second, we measure the distance from the object from the ground. Exactly t seconds after we threw the object, its height measured in feet is given by that equation. So I'm going to pause and put that in y equals. Okay, so it's in y equals. I'm going to go ahead and press graph even though I'm on my settings from last time. And I can't see enough of the x or the y axis, so I'm going to go to my window. I'm going to change my x. I'm just going to start out at -20 and +20 and see where that gets me. And then one thing you can do is, since you know this building is 1,680 feet, your y, min, and max are going to have to be pretty large. So I'm going to say -2,000 and +2,000. And then we're going to press graph and see what we can see. I can almost see the top, and I can almost see that this part over here where it touches the x-axis, so I'm going to have to go just a little bit bigger. So I'm going to say -35, 35, and if you're wondering where I'm getting these numbers, I'm just making them up. Just trying things. Not quite that big. Now hit graph, and hopefully we can see everything that we need. And the very first question, well, I got to go just a little bit more on the y's. So I'm going to do 3,000. So -3,000, +3,000. So hopefully we've done all that work and we finally have a pretty graph. And then the first question, when it says find h of 6, we don't even use the graph for. We actually need to use the table. So what that's asking us is, what is the height when the time is 6 seconds? So I'm going to have to scroll down to where x is 6 and look across to see what the height is at that time. Sorry, it's got to stop. Okay, so if I go up at 6 seconds, it is going to be 2,640 feet high. Then I've already talked about B. What does h of 6 represent? It represents the height at 6 seconds. C says, how far does the object fall during the 2 seconds between 10 and 12? So I'm going to have to arrow back down here. And I need the 12 second and the 10 second. So at 10 seconds, it is at 2,640. And then at 12 seconds, it's at 2,448. And you would just subtract those two, would be the answer for that one. And then D says, how long does it take for the object to reach a height of 2,640? So you have to be careful here because I think there might be two 2,640s. There is. So how long does it take? It takes 6 seconds for it to reach the 2,640. Okay? Because the 10 seconds at 2,640 is actually when it's on its way back down. So this would be 6 seconds. And then the next one, how long does it take for the object to hit the ground? Sometimes you can use your table to do this. I like to look at the graph, and I can see that it hits the ground right here. So I need to find that 0 that my cursor is hovering over, second trace. Number 2 for 0. Then I'm going to go all the way to that side and set my boundaries. So I'm pretty close to it, so I'm going to go left a few, then right a few. Check those arrows. They should be facing in towards each other. So 21 seconds is whenever it hits the ground. And then finally, what does the y-intercept represent in this problem? So that y-intercept is always your starting point, but it tells you that you're standing at the top of a 1,680-foot building, so it's the starting height of the object that you are throwing. Then number 19 says the Canton Flea Market wants to do a cost analysis of their profit based on the number of booths they allow, the formula. So the equation is given where X is the number of booths at the flea market. Which feature of this graph will give the number of booths that will maximize the flea market's monthly profit? Well, maximize means we're going to have to look at the maximum. So I'm going to put my dot right here. So the maximum number of booths would be the X, or the number of booths that would maximize the profit would be the X value of the maximum. If it actually wanted to know what the profits were, that would be the Y value of the maximum. Number 20, it says determine whether the function has a minimum or maximum. State the minimum or maximum. We've already done several like this. You just put this in your Y equals 2x squared minus 4x minus 1. Now remember, our settings are really weird on our calculator right now from our last problem. I can't even see that very well, so I'm going to hit zoom 6. That takes you back to your standard window. And it is a minimum. And then we just go through those steps. Second trace, number 3 for minimum. Get as close as you can, go a few times left, a few times right, and hit enter until it says minimum. Now remember, the calculator, don't put 0.99. If it's 0.99999, you can go ahead and put a 1, and a -3 would be your vertex. On number 21, we're going to describe how each of those is compared to the parent quadratic function, which remember is not always going to be given to you, so you need to memorize that that is y equals x squared. You can put these in the calculator. If you do put them in the calculator, in y1 you would put your parent function, and then in y2 you would put whatever the problem is, and then you would graph it and compare. I think it's easier just to do it by hand. So remember, if you have a plus or a minus inside your parentheses that is directly to the x and then squared, you're going to go, it's going to be opposite of the direction that you think. So this is actually going to shift right 4, and this -3 at the end is going to shift down 3. B, I'm going to start with the negative. That is going to make it reflect. The 8 is going to make it get narrower because it is higher than 1. Remember that we can also use the word stretch for narrower also. Then this +7 means that it's going to shift left 7, and then the +5 means that it's going to go shift up 5. And then finally C, the 1/3 in front, since it is less than 1, means that it is going to get wider. This -5 in parentheses means that it's going to shift to the right 5. Number 22 and number 23, you probably want to look at your formula chart, because we are going to write these equations in vertex form, and then we are going to transform them to standard form. So I'm going to write the formula up here. So there's the formula. Anytime you have a vertex and a point, you always want to start by finding A. And I like to label my point. So my vertex is the H and the K, and then the point is the X and the Y. And you're always going to find your A first. So we're going to say -10 equals A parentheses X minus H. So that's going to be -4 minus -2, and all of that is squared, and then plus K, but since K is a negative, I'm going to say -2. And then we're just going to simplify. So I'm going to simplify what's inside the parentheses first. So this double negative is going to become a plus, so -4 plus 2 is going to be -2 inside that parentheses, and I'm going to bring everything else down. And then I've got to simplify the -2 in parentheses squared. That needs to be the next thing that we do. So I'm going to say -10 equals a times negative 2 times negative 2 is 4 minus 2. Now, keep in mind, and I'm going to rewrite this a little bit better, we don't say a times 4, we say 4a. So we have negative 10 equals 4a minus 2. Now we can plus 2 to both sides. So negative 8 equals 4a, and if we divide by 4, a equals negative 2. So now we're going to plug into vertex form using our a and our vertex. So we're going to say y equals a is negative 2, parentheses x minus negative 2, and I'm going to go ahead and change that to a plus just so it's not quite so messy, and then plus k, but again our k is negative, so I'm going to say minus 2. So if it only asks for vertex form, that's all you would have to do, but this one wants us to go to standard form also, and remember these steps are always going to be the same. So in standard form, first thing we're going to have to do is we're going to have to expand or simplify this x plus 2 squared. So I'm going to do a little side work because I know I'm going to have to double distribute or FOIL that. So that's going to be x squared plus 2x plus 2x plus 4. So that's what I'm going to replace. So we have y equals negative 2, parentheses x squared, and I'm going to combine those like terms, plus 4x plus 4 minus 2. Next thing I have to do is I have to distribute this negative 2. So y equals negative 2 x squared minus 8x minus 8 minus 2. Very last thing is just to combine those like terms at the very end. Y equals negative 2x squared minus 8x minus 10. And then I'm going to do the same thing on number 23, but I'm going to pause the video so you try it yourself and then you'll see the work whenever you start the video again. And then there's number 23. Vertex form is up here in blue that I just drew an arrow to. Standard form is right here. Number 24, what is the GCF of the following expression? So between a 6 and a 48. 6 is the highest number that'll go into both of those evenly. They both have an x, and the lowest exponent on that x is a 1. They both have a z, and the lowest exponent is a 2. So the GCF would be 6xz to the second. For number 25, we need to name a common binomial factor of those two. So that means we have to factor both of them. So on x squared minus 36, if you notice that's a difference of squares, there is no GCF. That is going to factor x. Let me put my two parentheses. X, a 6, a plus, and a minus. And then we're going to have to do just a little bit more work to this one over here. We're going to have to do 1 times negative 12. Get our factors that add up to 4. It's going to be a 6 and a negative 2. And then I'm going to come over here to the side and I'm going to rewrite x squared plus 6x minus 2x minus 12. And then I'm going to group first 2, last 2. Then do the GCF. Then the second one, I'm going to take out a negative 2. X plus 6. So our factors are x plus 6 and x minus 2. And I'm going to come over here and I'm going to write those right underneath. X plus 6. X minus 2. So when it asks us which one it has in common, that is going to be the x plus 6, because that's a factor of each of those. Okay, for number 26, what is the first step to solve the following quadratic? Anytime you want to solve, whether you're factoring or whether you are putting it in your calculator, you always want to set it equal to 0. So that would be the first step. Next thing we want to do, number 27, we want to find the sum, so we're going to add those two together. When you're adding, you can just start combining like terms. So I'm going to look for, I've got x squared, and that's going to be 3 plus 8, so 11x squared. Then we've got x terms, so negative 4x plus negative 4x is minus 8x. And then if you have your 1 plus 17 is plus 18. Remember, if that were a minus instead of a plus in the middle, you would have to distribute that negative 1 to your second parentheses before you could combine like terms. The next one, we need to find the product. First thing I notice is that this whole parentheses is to the 0 power. And hopefully you remember anything to the 0 power is just a 1. Now when we come here, we're going to have to apply in this 2. Remember, this is what we do when we don't have a plus or a minus inside our parentheses. So we would have 3 squared, and then we're going to multiply our exponent. So that's going to be x to the 4th, y to the 2nd, z to the 6th. Then I still have to do this last one. So whenever I multiply 2 times 3, that's going to be y to the 6th. Then I'm going to simplify the 3 squared to 9. And because we're multiplying now, I'm going to add the exponent. So x to the 4th. I've only got the y's that I need to combine. So that's y to the 8th, z to the 6th. And then finally the last one, write the direct variation equation. That's y equals kx. What is the value of x when k is 42 and y is 12? So we know y is 12 equals 42 because that's k. And then we want to know what x is. So divide by 42 to get x by itself. So x equals, if we divide the top and the bottom by 6, 2 over 7.